Video 6.2, two sample confidence intervals. So our first scenario for today shows a pharmaceutical company is testing a new medication for cholesterol. 100 volunteers with high cholesterol are randomly assigned. So let's pay attention to that. It says randomly assigned. That's going to help us with our conditions. To either take the new medication or the current medication the company sells. After 6 months of use, their cholesterol levels will be tested to see if there's a difference in the proportion of people with reduced cholesterol. 39 out of the 50 subjects taking the new medicine had a reduction in cholesterol, and 34 out of the 50 subjects taking the current medication had a reduction in cholesterol. Construct and interpret a 95% confidence interval for the true difference in proportions that people who will have, we don't need like in the study, who will have reduced cholesterol after 6 months on the medication. Okay, so let's take a look. In our state, that's where we're going to define our parameters and put our confidence level like we discussed in the last video. So our parameters, we're looking for a difference in proportion, so we need to make some decisions here. So when I was reading through, a lot of times I'll write these down as I'm reading through what information the problem is giving me. So I saw right here 39 of the 50, so this is a p-hat, 39 out of 50 were on the new medication, so I'm going to call that p-hat N. Okay. And then 34 out of the 50 stay on the current medication, so I'd call that p-hat C. So then that's going to be 34 out of 50. That just kind of helps me, because now I know I've got two different things going on. I'm going to use a variable here to kind of help me keep track of who is who. So because I am looking at that, I'm going to say we want to know the true difference in proportion, and they're talking about the new medicine and the old medicine, so we can pick an order because they didn't tell us here, but to subtract. But I'm going to say the proportion of new minus the proportion of the current medication. And so I'm going to define these variables when I write this, and I'm going to use my question to give me my definition for my parameter. They have a few more words than we really need. So we have here the true difference in proportion of people who have a reduction in cholesterol after 6 months of the medication. Alright, so here's my parameter, true difference in proportions of people who have a reduction in cholesterol after 6 months of medication. So you could have written exactly what they had in the question. That's fine. You wouldn't have been wrong. I was just trying to condense it down a little bit because it was a lot of words. Now, I said N minus C. So I'm just going to say new medication minus the current medication. And what that does is that just defined what N and C were for the reader, so they know N stands for new medication, C stands for current medication. I have a confidence level of 95%. So I've got that. That's what has to be there. I also like to put my statistics, so I've got them handy for the rest of the problem. So we had our p-hat for the new medication was 39 out of 50. Which gave me a p-hat for them of 0.78. And then I have a p-hat for the current medication of 34 divided by 50, which gave me a 0.68 for that group. That way I've got them available and I'm ready to go. We're talking about proportions here. Anytime you're talking about proportions, we're talking about Z. So when we go to name our procedure in our plan, we're going to have a Z interval because we're creating a confidence interval. We have two separate samples. We have the new medication people and the current medication people. So this is a two sample Z interval for, and we're trying to infer back to the population, so Pn minus PC because that's what we said up at the top here. Okay, so now we have random. Pay attention here. Remember when we were reading through how we said, oh, this says random assignment. It didn't say random sample. It's a random assignment. So for our random here, we're going to write subjects were randomly assigned. If it doesn't say random assignment, you're not going to write this, okay? So our subjects were randomly assigned, so we're good there. So 10%, we don't actually need to check if it's random assignment. Now you wouldn't write that there. I'm just doing this to help you remember that. But we were struggling with this a little bit, so if you feel better going ahead and doing the the 10% check, go ahead. They're not going to count it wrong. 100 is less than or equal to 1/10 of all people with high cholesterol. Okay. So you wouldn't be wrong, but you didn't have to check it. And then for your normal, remember this is your N times P, and we discussed in the previous video, you got to show your calculations out. So here, there was 100 people and 50 were put in one group and 50 were in the other group. So our N's are all going to be 50. And so we have N times 0.78 and N times 0.22. That's for our one sample for the current medications. And so N times 50 times 0.78 gives us 39. 50 times 0.22 gives us 11. Okay. Then we have for our other sample, there's still 50 people in that group, but their p hat was 0.68. So we had 34 there. 0.32, so we had 16 there. All of these are greater than or equal to 10. Okay. Now, before we leave this check our conditions, I want to go back here to our random. This is going to be our first tip right here for our AP tip of the video. Is you need to indicate whether there's random assignment or random sample. So we're going to use our space at the bottom of the paper to answer questions. So we'll go ahead and use the space at the top. When checking a random condition, clearly indicate whether you have a random assignment or a random sample. You can't just write the word random, or both. Okay? That can happen occasionally also. So we had random assignments, so we had written that the subjects were randomly assigned. All right, state plan. Now our next task is the do portion. So I'm going to give you the specific formula from our formula sheet. It's 2 samples and we're talking about proportion. So on the formula sheet, we're going to have 2 samples, okay? And so we're going to use this standard deviation to help with our margin of error. All right. We have this pooled thing here, but remember that is only for significance test, and we're doing a confidence interval. So we don't even want to look at that. We only want to use the standard deviation as part of our margin of error. So our specific formula, before we plug everything in, you're going to have p hat new minus p hat current equals its proportions, so you have a z star, and then your standard deviation p hat new minus 1 minus p hat new divided by the sample size of new plus p hat current times 1 minus p hat current divided by the sample size of the current. Okay. Now, to plug all of this in, I'm going to show all of the work. Minus 0.68 equals, oh, it's plus or minus, okay, Z star for a 95% is 1.96, and then we have 0.78 times 0.22 divided by 50 plus 0.68 times 0.32, and that sample is also 50. So when I calculate it all out, I got a negative 0.0729 to 0.2729. You could have rounded a little bit differently, so you could have written 0.073 to 0.273. Same thing. So you can check this in your calculator by going into the test again. So we'll go stat over to test, and this is a 2-sample proportion. So there's your 2-sample proportion. They say 2 proportion Z interval. So going back to our p-hats, we had 39 out of 50, and the second one was 34 out of 50. Our confidence level was 95%. And then we're going to calculate it, and we should match. We have negative 0.0729 to 0.2729. So we are good there. We calculated everything correctly. So you're just using the calculator to verify. If you feel very confident, don't worry about using the calculator. Now for your conclusion. So go ahead and pause the video, write your conclusion, and come back and see how you did. Alright, so for the conclusion, we are 95% confident that the interval that we have captures the true, and then what did you write up here in your state? Just reiterate that, and I even reiterated my subtraction order. Okay, so that's all part of it. Make sure you include it in your conclusion. Now, this question has a follow-up question. It has a part B. Part B says, does the company have convincing evidence that there is a difference in the proportion of people with reduced cholesterol? Between the two medications, is there convincing evidence of a difference? Well, looking at the interval, 0 is in the interval, meaning no difference is a plausible value. Okay, so we want to write no. And of course, you can never just answer a question with no. Since 0 is in the interval, it is plausible there is no difference. Because 0 is a plausible value. Now I want to add a little bit more to this to get the points for AP. We said 0 is in the interval, it is plausible, there is no difference. Why is that true? So convincing evidence is really starting to talk about significance test. So if we have a 95% confidence interval, that means we have a 5% alpha. So using alpha equals 0.05, there would not be convincing evidence that there is a difference in proportions. Okay, so you just want to follow up your follow-up, really. If we're talking about a difference in proportions, and 0 is a plausible value. That means there's no evidence that there's a difference. So that's what we're saying here. A 95% confidence interval would be a alpha 0.05, and there's no convincing evidence that there is a difference. If we had a 99% confidence interval, we'd have an alpha 0.01. A 90% confidence interval would be an alpha 0.1. Okay, so hopefully that makes sense, because that's going to be our second AP tip for today. Right. When using a confidence interval to decide if there is convincing evidence for a claim, you must reference the confidence level and alpha. All right, so hopefully this was helpful. Let me know if you have any questions, and I'll see you in class.